Yeah, then I'm sharing here. Okay, I'm sharing now the Microsoft Word. This is the study guide for quiz for exam 2, and the same thing for I can add to this. You can make the same thing, quiz 2 and exam 2. So you have a snapshot of it.
Yes, yes, sir.
Okay, so if you have snapshot of it, let's take the first one. Okay, so we are taking the first one. And I will highlight yellow that we cover this topic. I'm going to open my Google Chrome. Okay, and then I will say I will say balancing code. Okay. I will share it. Just hold on. Worksheet. No need for us. Yeah, I'll share it. I'll stop sharing this Microsoft Word study guide. You have it already, correct? So I'm sharing the Chrome. You tell me. So we have, look at this worksheet. We have 1, we have 2, 3, 4, 5, 6. That's the second one. Half-life will come later on, but 6, 7. So whatever you like. So I will go again through this again, and you decide which one you like. So those mostly without answers on purpose, so you can study them and then check with answers. So anyone in particular, just tell me what the name of the worksheet, title the tab, like Amazon Web Service or Weebly or Department of Chemistry, Texas A&M, Department of Chemistry, Texas and A&M. So which one you like?
Well, I can do this.
Which one?
The second one.
Second one. This one here, Texas. This
Yes.
one?
Yes, sir.
Okay. I want you to help me doing this. Have your pencil and pen.
Okay.
Pencil or pen and a piece of paper. And here in this, they give you all the information. Let's make it bigger here. You can see it much better. Okay, can you see it much better now?
Yes, sir.
Take this one down. Okay, so you can choose out of this. This is typical one. Choose the ones that are difficult ones. So like, I'll give you homework here. 12, write down.
12.
14,
14.
15,
15.
and 16. Those are the most difficult ones, I think, because they have too many. So it's 12,
Okay.
14, 15, and 16.
Yes, sir.
Yeah. And, oh, there are many. Oh, wow. Look at that. Look at that. We'll do those and then we'll balance then the next set. So you have 3. Take a couple minutes. Nobody's here, so you are the only one. You have the big advantage on over the board. Everybody here, because nobody's here. So
Okay. You want me to try number 12, right?
Yes, try number 12. Tell me what the answer is.
1.
Yeah.
Okay. Is it possible for it to be a little bigger?
Okay, I will. Just hold on. Hold on, hold on.
Okay.
Can you see it now?
Yes, sir.
Take your time. 12, 14, 15, 16. 4 of them.
Yes.
Take your time. Take your time.
Okay, this is do you want me to say if I finish the 12, I should tell the answer?
Yes.
I think I got He, helium, and it's proton decay.
You said helium.
Yes, He.
Okay. So did you calculate 32 and 4? That's not H. That's helium decay because helium is out. Helium is alpha decay. Helium called alpha
Yeah,
decay.
yes, alpha decay. Alpha.
Alpha decay. That's correct. Yeah,
I
that's
got
correct.
4 and 2, which is helium.
Now hold on.
All
You
right.
said you got what?
I got 4, 2, which is helium.
You said you got here.
No, I did 12. Number 12.
Oh yeah, sorry.
Mm.
So here 12.
Yes, He.
But you gave me the correct answer, but your approach is not correct. How you know that's helium? You said that is 4, and the
Yes.
bottom is what?
2.
2. Now 2 plus 14 here, that's 16, correct? And this is 15 and 116. We know the element by not the 4 atomic mass, by the
Yes, atomic number.
by atomic number. You told me you recognize this by 4. No.
No, I said no.
Not,
I said
yeah, atomic number is very important to know what element you are in. That's correct. Let's do
yeah,
14. Let's do 14.
okay.
So, and this is called alpha
Decay.
decay. Yeah. I'm writing with the mouse. It does not write very well, so I apologize.
It's okay.
Yeah, I'm writing with the mouse. It's not writing very well. But anyway, alpha decay. Okay. So let me take this one out. You have snapshot of it already?
Oh, you mean the answer?
Yeah.
Yeah, I wrote it down.
You have it correct. You have it correct anyway. So let me
Yes,
take it out.
I wrote it down.
Yeah. Now 14.
Okay. This is American.
What's the atomic number?
95.
This is X. What's the atomic number at the bottom?
95. 95.
90 what?
95.
5, correct. I heard 85. No, that's not correct. This is 95.
Yes, 95.
The top, atomic mass number?
239.
2, 3, 9. And X is what will be? A what? AM?
Yes, AM.
That's correct. So you got that correct.
Okay. So this, do we call this decay one that's
What you are producing? Neutron. That's a neutron decay.
Neutron decay, yes.
Correct. Neutron.
Neutron decay.
0, 1, neutron decay.
Yes.
Okay, check it out.
Yes, sir.
Do 15. Do 15. Just the way you can tutor, I can give you the answer, but this has to be coming from the student so the student understand. If you make a mistake, then I will coach you, I will guide you to the correct answer.
All right, sir. Aluminum. Okay, this is aluminum.
You said aluminum, okay, let's see. Just following whatever you are saying, telling me. So this is aluminum. What's the atomic number for aluminum?
Number 15. 15.
Atomic number 15?
Yes, I did 15.
Could you look at this again? Is aluminum atomic?
I did number 15.
Oh, number 15. Okay, not 14.
No. 15. We have done 14.
Okay, so we have 30 and so you said AL.
Yes, sir.
So that's 30.
13.
That's 13. That's aluminum. Number aluminum.
Yes.
What's the atomic mass or mass number?
25.
So that's 39. 39 and here 64, correct?
Yes.
64 minus 39, correct?
Yeah, give me 25.
5, 2, correct. 5 and 2. That's correct. The answer is correct. Do 16, and then I'll give you one of your choice at the bottom. Take one letter. Let's do 16 and the one from choice, and I think you are very good in this.
Okay,
What is this? What is the decay is this? What the decay?
Still Newton. Neutron decay.
Neutron.
Neutron.
Yes, correct. Neutron decay. That's what you are getting. Okay, that's good.
320.
Yeah, because the decays are alpha,
Yeah.
beta, gamma,
Gamma.
correct? Alpha, beta, alpha,
Gamma.
gamma is not correct. Just hold on. I'm just taking this gamma out, this alpha here. So this is gamma is like this, proton.
Proton.
This is negative, zero charge, -1. Then you have positron. This is 1 and 1.
Gamma.
This is helium,
H. 4, 2.
4 and 2.
Yeah.
And then there's protons, and then you have positron.
Neutron. Yes. 0 and 1.
This is a 0 and +1.
Plus 1.
And then the last one is neutron, 0
Neutron.
charge, and 1.
1. Okay.
Yeah, so 1 alpha, beta, gamma, protons, positrons, and neutrons. Those are the ones we are dealing with. So are you doing 16?
Yes, sir.
I think you got this one under control, so you have it. So I don't know why students are making, very low grade. It's open book. Why? The time is enough. I think 90 minutes or so. Plenty of time they have.
Okay, this one is hydrogen.
What's that?
Hydrogen, H16.
Hold on.
Number 16.
What's the element?
Hydrogen.
Hydrogen. Okay. What's the atomic mass, atomic number at the bottom? Is 1.
1, yes.
30. Okay, and the top?
1, 2.
So that's another isotope of hydrogen called deuterium. This is called I can't write it with deuterium. This is called proton.
Yes.
And you have a third isotope called tritium. That's proton here.
Okay.
Then you have another one, H. All of them, they have the same number of protons. This is 3.
Yeah.
Atomic mass. So atomic mass can be 2, 1, or 3. This is called tritium. Tritium. IUM. So we have proton, deuterium, tritium. Okay, so you can take snapshot of it, but that will be recorded anyway. It's recording, so you can just repeat this one here again. So now I'm taking one last one of your own choice now. That's my choices. You take from the bottom here, 17 to 24, or 26, 27, or 30. So I have to make it smaller so you can then decide which one you like. One, just only one. Let's make it, so here it is. Now we'll go and make it smaller here. Make it bigger than when you come to the one you like. Wow, that's a lot. You can see the first batch from 17 to 32. And this just eyeball one of them.
$17. That has okay, this thing is the same thing. Okay, maybe
17?
let me Yeah, okay, let me try 17. Because
Okay, that's from your choice. That's the last one. I'll make it bigger for you. I'll make it bigger so you can see it. Is this good? Can you see it?
yes, sir. Uh,
But that's not the whole thing because you will be missing something here.
yes, I'm missing something. Okay, something.
That's what you are missing.
Okay, yes, I'm seeing it. Okay. Mm.
You have one neutron and two neutrons outside. So still this is what?
You said
This is neutron what? Decay, correct?
neutron. Yes, yes, 1 and 0.
Yeah.
Neutron, yes.
Take your time.
Okay, that's
'What's the atomic mass here?
50.
That's correct. I mean the atomic number, sorry. Atomic number.
Yeah, 50. Atomic number is 50.
What is the atomic mass then?
139.
236,
Yeah,
95,
139.
139. What is this element called? You look at the 50, correct? What this element is? Look at the periodic table.
Same?
Are you sure? Did you calculate this 2 here?
Yes.
The 2 here, correct?
2 times 1,
So
yes.
2 plus 1 is this 141, and here is
236.
236. This is 95. So we have 95 plus 2 is 97. 97, and this is the other one is 2, 3, 6,
Yes.
minus 97.
No, minus 97. You wrote 79.
79.
Mhm.
97. Correct. This is 9. This is 12, 3. That's 1. That's correct. So what's the name of the element and what type of decay we are dealing with? So the
The element
question
type
is
is tin. Tin.
10.
SN, yes.
Okay, that is SN.
Yeah.
50. 139. What decay is this?
It's the neutron.
The neutron, correct. Although you are bombarding with neutron, but still you are getting neutron out of it, even more than that. That's decay. Okay, that's it. Let's do half-life.
Yes.
For half-life?
Yes, that's what I'm struggling with.
Okay, okay. No
Yes.
problem, no problem. That's the same thing I showed you. You have to do what? Half life calculations worksheet. Without answer, we don't need answer. We have to come up with the answer. Okay. So here, now, let's have life problems here. Let's have life practice worksheet. This is skill worksheets, half-life calculations, extra practice, half-life worksheet, whatever you like. Look at them here all. Here it is. See here, all of them. You can Google with me in your laptop and then decide which one you like. So take your time because that's the area you are suffering from. So we can still manage it. So let's look at the Google Half-Life. The same thing I did. Half-Life calculation worksheets and look which one you like to have because there's too many of them here. You'll not be able to look, see how many there are. Way too many, way too many. See? So
Yes.
Google that and come up with one. We'll do one, that's enough. Because we have still a couple of topics we have to look. Half-life now, that's the second topic we have to cover. And then we'll go protons, electrons, and all the stuff here. So
Problem let's say example. To do the one that has the focus. Can we do half-life worksheet? Where is it?
tell me which one, because I told you to open your own search, the same thing I did, half-life calculation worksheet. And then which one you like now.
Okay.
Look at all of them. We'll do just one, and then all the stuff you can look at another one by yourself. And if you have any problem, just email me with the problem. So I did not take the answer. We don't need the answer. I want you to get the answer.
Yes.
Okay. So which one? One?
Half-life problem, the weekly one.
Oh, the Weebly one. First off, which one?
Yes.
That will be easy. That's the way they solve it. I wanted to solve it the way I showed you with the formula. The formula is I don't like this. I don't like this taking half, 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 half. No, I would like to see the calculation we did. So let me
Okay.
just
I
write
mean,
that
look back.
formula. If you can remember the formula, I'll remind you with the formula. The formula is the M.
M in M final.
Yeah, just hold on. M F final equal M
Initial.
initial multiplied by half, and this half over N. N equal to total time multiplied by half-life, which is cycle, one cycle by time. Which is this one here is our half-life. So do the first one and you can share, I will stop, you can share your calculation. Show me how much you got. The answer is still there. We know the answer, correct? 0.2125. So we have isotope of cesium with the atomic mass 137. That's the way we can write isotope. Has a half-life of 30 years. If 1.0 gram of cesium, I will put 3. I have to put 1 point because our answer is in 3 sig fig, so I have to be careful to be consistent here. Three, not this is out. Take it out here. 3 grams. 1.3 sig figs of cesium disintegrates over a period of 90 years. That's absolute value, so not part of sig figs. How many grams of cesium-137 would remain? Would remain means we want to get the final, M final. And you started with this one. So solve it, and then I will take out my sharing, and you share your answer with how you do it. So you can do it with the pen or pencil, or just or you do it with your hand, then upload it as with your phone, through your phone, or just Microsoft Word, and then you type the answer, the steps. So you want me to do the first one for you?
Okay.
Okay, let me take this the whole thing. You have everything here. It's will
Yes.
be recorded, so you can recover. So
Yes.
I don't like this type of solving those like this, because if you have too many half-life, so how will you do? This is just, this is just 3 half-lives, correct? But if you have get 10 or 20, how you do it? It's not a good idea. And that's not a good approach. Sure, not recommended anyway. Not recommended, REC. So I will say, first of all, I need to get my N, correct? My final will be, the initial is 1.00 gram multiplied by half over N. That's the whole thing is about N, how to get N. Well, N is the total time, correct?
Yes, sir.
The half-life is 30 years. So total is 90 years. Multiplied by 1 cycle, and half-life is 1 over half-life of 30 years. 1 cycle, correct, per 30 years. So this one here, how much? 3, correct?
3, yes.
So the N will be then 3. So half power 3 multiplied by 1.00 gram. Are you getting this? I think you are getting this, yeah. This is the correct answer, I think. With 3 secrets. Okay, did you get that?
Yes, sir.
Half to the cube, half to the cube, multiplied by 1. So that will give you the answer. I think I see it as half multiplied by half. That's 1/8. 1/8 is 1.125, correct. So let's do choose one of those here, whatever you like. Okay. Maybe 3 and 4. 4 is a little bit different. Okay. A little bit different. So we want to see how you do 4. First of all, let's do 3 and then 4. And I think, and then you can see whatever one you like. Again, I am not recommending this type of, this is not good. Those type of solutions not good. This type of solutions not good. The answer might be correct. The answer might be correct, but it's not recommended this way, okay? So not recommend this way. So anyway, so let's do 3 and 4, our own way. Our own way. I mean, our own formula, So you want to share, do it, and then Microsoft Word, just type you don't have to be subscript, MF, just without subscript, just MF equal mi multiply x sign x, and then in parentheses 0.5, and then superscript n, and then calculate n, and then plug in all the numbers. You can type those here, Microsoft Word, and show me. I will get out of the. So first of all, whenever you are ready and you want to show, I will get out of sharing. You share your
Are we
screen.
doing number 2? Is that number 2?
No, number 3. Number 3 is
three.
easy. Number 3 is easy. Number 3. Number 3,
Okay.
number 4, yeah.
Sodium.
Do 3 first, and then we'll do 4.
Yeah, can I explain what I did?
Uh, can you show me? Did you type your answer inside
Uh,
the Microsoft Word? I will stop sharing here. Type just small time typing. Type.
okay, I should go to Microsoft Word.
Yeah,
Or
type. Yeah, open it. Type. Yeah, at your steps typing. It has not to be subscript or something. Just MF equal MI
or
multiplied by
should
half.
should
Multiplied
I
by half.
write in the
Yeah,
chat?
type. Yeah, type. Or
Okay.
you can write. They have a they call it whiteboard, but I don't know if we can. There is a whiteboard somewhere.
Okay. Let me see.
Looking like there's a whiteboard somehow there. We can type on it. So don't see it here, but let's see. There is. I don't see a whiteboard. So caption there. Record. I'm trying to get the see apps. There is some apps here. See what they have. Yeah, there is no whiteboard here for you, and I don't see even the whiteboard. Unless when you share, then you can see the whiteboard. Click open Microsoft Word, and then click on share the button, and you'll see a whiteboard somewhere. Yeah. So open Microsoft Word.
I can type it on the chat.
Well, you can type it in the chat. That's fine with me.
Yes. So what I did was MF equals equals MI multiplied by um, 2. I don't know how I would do raised to power n.
Well, this number. Click on number shift and number. Hold on. This number 6. Shift number 6.
Shift.
Put your hand on a finger on shift and then hit 6. This is like
Okay, press shift and number 6.
yeah, that's like a carrot or something, you know.
Work. Let's see. Maybe I will do put it in brackets.
Yeah, the whiteboard, if you share, then it will appear. I'll show you how to do it. Just finish your stuff, then I'll show you how to do it. Your time, take your time. We're almost done with the chapter, the nuclear chemistry chapter. But we have to know just what type of decays, what type of nuclear reaction we are dealing with. That's very important.
Uh, Okay. I'm not finished. Minute.
Okay, that's good.
Minutes.
You have to get the N.
Yeah. That's it. I have, I see. Practice. Let me send this one. And then continue. Icon 0.2 is
Okay, that's correct.
is one is equal to 0. Okay.
So you have to work
Is
out MI.
yes, Emma, that's what I'm doing.
Yes.
Is it the 5.0 mg that I will use as the signal figure?
If it's 5.0, that's your answer has to be 2 sig figs.
The signal figure.
Yeah, their sig fix is not correct. Their sig fix is not correct.
The what?
The answer, their sig fix, if you look at we will look at their answer later on, but what's your answer is coming? Your answer has to be 2 sig figs.
Yeah, my answer is 5.0. Let's be 4.0. 40, let me see, 40. Mg. I don't know which one is will be right. That 4.0 points.
So what is MI? What is MI will be? MI will be MF divided by, correct? Half over power N, correct? What is half power N? N is 3, that's correct. So you
Yeah.
have 8.
8, 1 over
1 over 8. So 1/8 you divide 5.0 divided by 1/8. And that's your answer.
1 what? 1/8?
5.0 divided by 1/8.
Yes, that's what I got.
How much is it?
0.0 divided by.
Right, yeah, type this, and your answer has to be rounded to 2/6. First, write the whole answer, and then
Yes.
put the whole thing to 2/6.
Yes, I have 1/8 divided by 5.0 mg. 0.6.
Type it there.
mg.
The unit will be what? No, that's 1/6. You have 5.0 is 2/6.
Is 0.3 mg.
No, that's not correct. The MI is the 5 in the top divided by the. See here, look at the again.
I said it's 5.0 divided by 8, right?
5.0
divided by 8.
now divide by 1/8. So the 8 will come up in the top. So that 8 multiplied by 5 will be 40.
Yeah, that's the first thing I did, which I got 40. 8 times 5 gave me 40.0.
Yeah, that's correct. We don't care about the solution is not correct. What were placed in the reaction vessel, see, was removed from the reactor. This was removed from the reactor. That's the final. Well, it looks like, look what they did. How many milligrams of were placed in the reactor 30 minutes later? Oh, later. We did a mistake here. Let me share with you here something.
Okay.
Not look at the see, we did not look at the keyword later. Later, that's MF. See, that's later is means this is how many they need the MF, not the MI. The MI was placed, that's 5.0. See, we missed the letter. There is keywords you have to look. 5.0 multiplied by 1/8. Correct, but that's 6 is not correct. 0.63 grams. Did you get 0.63 grams?
Yes, I sent it.
Yes.
0.63.
Yes, that's correct.
That's what I got. Yeah.
Okay, yeah. So I think do you need any another one? Other one? Number 4. Five, 6. That's what I told you. This is not recommended. Look, when you have too many half-lives, look how many.
Yeah.
See how many? Two. That's a big error. It'll give you a large error here. That's time of calculating. But if you put it in our own way and looking at the keywords, like later or afterwards or whatever, then you will be okay.
Yeah, I think my issue with this work is to interpret correctly, to understand the words, so I will know what I'm looking for. Hello?
You do 6?
Yeah, I said my issue with this is to interpret the words.
Well, you have to look.
To know what I'm looking.
let's look at the 6. Just give me the MIMF. Where is MI? Where MF? What is the N here? It said the half-life of plutonium-218, 3 minutes. So it means that's the half-life is 1 cycle. The tab 1. We don't write cycle 1 per 3 minutes. ARMN. We don't really type cycles, understood. We write just sometimes just 1 over 3 minutes. This is the half-life. What we have to look for? How much of 2 grams remains after the keyword after. They are looking for MF.
MF.
Yes, after, later, afterwards, you know. So if to buy some, suppose you wanted after 15 minutes, that's the total time. That's total time. Total. Total time. I'm sorry, I'm just typing with the mouse. It's not typing very well. But anyway, so, and then multiply it by 15 minutes. So how many we have? 5, correct? 3 minutes, 15 minutes. You have 5 cycles. That's your N. That's 5 cycles. Yeah. Okay. So then you have MF. How much of the 5 grams sample remain after? So that's what you started. How much will be remaining after? So the MI is MI is 2.0 gram. They are asking about the MF, correct? So it will be 2.0. That's MI multiplied by half over 5, correct? That would be MF. Try to see if you get this one correct.
Okay.
2 gram, correct?
2.
If you require to have a life of, suppose you wanted to buy some isotope and it requires half an hour for it. Oh. We did it half an hour is 30 minutes, not 15 minutes. So we did a mistake here. The total time is not 15. That's a half-life, correct? Half-life is the half-life is 3 minutes, 1 over 3. But the total time is what? Is 15, correct? The times 15. That's correct. Yeah, 15 total after 15 minutes.
Yes.
But then they need, by some of the required, like how much should you order if you need to use 0.15 grams of this? How much you should order if you need to use? Okay, so tell me first of all, is 2 multiplied by half over 5? How much is this? Your final, how much you get out of this whole thing with half-life? And then we'll look about this. How much you should order?
Figure. This single figure will be 0.1.
Yeah, this one after 15 minutes, but we have to do the same calculation, but it's totally different. Is the half instead of here total time 15, the total time is half an hour, 30 minutes. So after 15 minutes, you get the same answer.
2.0 times half into raised to power 5 is 0.1.
Multiply by 2.
Yes, 0.1.
That he got or she got 0.0625. And that's
Yeah.
wrong. 2 sig fix, it has to be 2 sig. That's 3 sig fix.
Yeah,
0.63.
oh, 0.1.
0.1.
Yes.
Half of 5 and then multiply by 2. How much is it? He got,
Yeah, just give me
yeah,
0.065. And the two significant figure, right?
yes,
2.1.
2.1.
Yes.
But he is getting is, see what they got here? 2, 2. That's what we got, the same thing. That's what we got, 2.
Yes.
This is half
Yeah,
over
in
5.
5 places. That's
Did you
what.
get this answer? Did you get this answer?
Yeah, I got it. Then when if you convert it to two significant figure,
Yes, two significant figure, you take the 5 out. It will
yeah,
be 0.063, right? The 5 is out.
yeah,
That's 2 sig figs. Did you get something like this?
yes,
Okay, so now let's do the second one. The second one, the mass, the half-life is changing to what? And it require half
half
an
an hour.
hour, half an hour, correct? So this is half an hour is 30 minutes.
2
So you have
minutes.
30 minutes total time, and the half-life is 1 over, where is half-life? It's 3 minutes, correct? 1 over 3. That is 10, correct? Total is 10,
Yeah, yes,
correct?
yes,
Is 10. That's 10 cycles. So will be the MF, if you, how much you to order, the final MI is 0.1 multiplied by half over 10. And this is what you get, I think. Try to get it. So half over 10 multiplied by 0.1 gram, 0.0 gram. So it is 0.0 gram, this one here.
First of all, 10. Then
Get it? I don't think so. That's correct.
oh really?
Yeah, because it said you need 102 grams. How much should you order if you need to use 0.1 gram? Well, if you use, that's the wording. You have to look at this. You want to use only 1.1 gram, and the time is 10 cycles, correct? So this one here, that's MF, correct? That's we got right here.
Yes.
So
Yeah, what do I call 0.1 times 1 times half raised to power 10
Well, here, no, that's because how much you order, if you need, that's your, if you need, that's the problem. That's your MF. So MF is given to you. So you have to, this time you have to look at the, as you said, the wording, MI.
Yes.
MI, half over 2/10. And you have to place this, the final placing is 0.1 over half over 10. So you have to get the MI here. The first one is MF, the second one is MI.
0.1 times this part. MF is no. Okay, we are looking for MF.
Yeah, so that will come 102, I think, but you have to make it two sig figs. How you make 102 to 4, 102.4 two sig figs? You have to go for what? Scientific notation, correct?
This will be that over 10, 24. Oh,
Yeah, that will be,
10,
if I
24.
know the answer is 1.010. I went to the left 2 digits, 2 grams.
0.12349766. Okay, we are putting it into two sigma figure.
Yes, I put it 1.010 power 2 grams.
Okay, because it
I
is
went to left, left. I went to the left 2 digits. You can't go 3 digits. You can't go 3 digits. Will be 0.10 10 power 3. You can go 3 digits. 0.10 power 3. Yeah.
What I got here is if we say 0.1 times half raised to power 10, right? Hello?
Yeah, I'm listening.
Yeah, if I 0.1 times 1 raised to 1 times half raised to power 10, that gives me 1 over 1024.
Yeah,
So,
but what's the, you see, this one here, this value here, you can transfer it into 0.10 power 3.
yeah, I didn't get that.
0.010 power 2. It depends what you are doing it.
Yeah, I didn't get this number.
What's that?
I didn't get this answer. 0.1, 0.1 gram into bracket half raised to power 10.
How much you got? 100?
Half raised to power 10.
You did not get one of those here?
No, what I'll get is different because if I say half raised to power 10, that gives me 1 over
the first one we get MF. The second problem we have to get MI, because how much you place at the end, 0.1, how much you initially will be. So that's then, yeah, the second one is this is MI.
Okay.
And this is MF.
So that would be MI.
Two problems. That will not come the final exam or quiz or something. No, just ask one problem.
Okay, 1024. Okay, I see it. 1024 times. Okay, yeah, that's it. That's correct.
Okay, you got that. That's
Yes.
excellent. That's excellent.
So 1, 2, that would be 1.024 times 10. 3.
Okay, so if you round it to 2 sig figs, it will be something like this here or this. Power 2 or power 1, whatever is
Okay.
that's scientific notation.
Oh yeah, 10 raised to power 2. Yes.
Okay,
Yes. Yes.
so we are done with this. Let's move quickly here. So let's do the nuclear reactions. That's the last topic here. Nuclear actions. So worksheet. Okay, so which one you like? Just type nuclear reaction worksheet in yours.
Okay.
Look at them, not balancing. This time just type, and then with this chapter is done. Then we'll do naming covalent, naming ionic with single charge, with multiple charge. And then just the polarity of this pair, whatever. So
Okay, so you say I should just type nuclear reaction
reaction worksheets.
worksheet. Okay. Yeah. Wow.
Which one you like?
Fine.
Yeah, you open one or two of them and see decide which one you like. It's just too many.
Okay, let's do this one. The second one. The second one. Oh, okay. Oh,
This one here, you like the Weebly one, okay? Okay, so what type of reaction here we have? We said we have the main reactions. We have the decays, and the decays are alpha, beta, gamma,
yes.
proton, neutron, and positron. Those 6. Now
Yes.
those are the decays. But how many types we have? We have 2 types: fission and fusion. Fission, you bombard the nucleus with the neutron or alpha or beta radiation to shut down, to break down the nucleus into um, small new elements, correct? And
Yes.
neutrons will come out of this. So chopping or breaking or bombarding the nuclei of these isotopes, that will lead to new creation of new elements. That's called fission, V-I-S-S-I-O-N. If you combine the nuclei of those isotopes, like you combine the tritium, hydrogen atomic mass 3, with proton, hydrogen mass 1, you get helium.
Oh,
That's called fusion. If you can take 2 deuterium, mix them together, you get, again, helium, He4, the bottom atomic number is 2.
yes.
So, and that's what all the so now you tell me what's the first one?
First one.
Yeah, here, can you see it?
Yes, sir.
Helium is a tritium. Tritium is decaying to what, and then what the decay. I don't want to give me the what the element is coming out,
Okay.
but what's the decay is. What's the
That's
name of the reaction? Yeah, what's the decay? What we said
that's
we
better.
have 6
Better.
decays and we have fission and fusion. 3 types of reaction. Fission, bombarding, creating new elements. Fusion, combining nuclei, get one single element. And the third one is the decays, which has 6 type of decays: alpha, beta, gamma, proton, neutron, positron. You got it? So what's the first one? What's the first one? What type of those 3?
Is
Fission, fusion, or decay? And what type of the decay is that?
the beta decay?
That's beta decay.
Yeah.
Oh, beta decay is helium. Is this helium coming out? 4 atomic mass and the atomic number is 2? No. You have atomic number is -1 or charge -1. That's what?
Atomic number is -1 here.
Yes, what's that? That's not helium, not alpha. No, that's correct. What's
No, I said beta. Hello?
yeah, I'm looking at this.
Isn't that beta decay?
That's a beta decay. Yeah, that's a beta decay. Now you said alpha.
No, I said beta.
Oh, okay.
Beta.
I heard alpha, but how about the second one?
Second one.
They are getting. I'm not looking at this. I'm looking at this decay here. That's the decay here.
Okay.
Or vision. Or fusion. What type is this? It's coming. Number 2.
Let's see.
I'll help you a little bit. Correct? That's correct.
Alpha decay.
That's alpha decay, yeah. How about the second one? After it.
Huh?
Number
Number
3.
third. Number 3.
Yeah.
Number 3. Let me see. 144. 144. 0 and 0 and -1. That is beta decay.
Okay.
Beta decay.
Number 4.
Number 4. Zinc. Very. Zero, that would be 0. Okay. 5.
Positron. That's positron. 0 mass plus 1.
Yeah, +1. Yeah.
How about number 4?
Number 5.
Number 5, yeah.
5. Okay. 0 and 1. That is
Positron, correct?
Yes, positron.
Okay, so, and I need to see if we can get vision and fusion examples.
Mhm.
Okay, this one here, number 14, what we call this? It has two types combined. It has two types. What you call the first? What you call this? If you're bombarding an element with a neutron or gamma or beta or whatever, that will be what? Because you are creating new elements or elements. Vision, correct. But at the same time, you are generating helium, correct?
Helium.
And let's look at this. Helium is 4, and this is 2. This is 3, and this is, let's see, 4, 3, 7, and this one here. Have to balance it, correct? So that's is 1 there. Oh, hold on, this is 1, 0 there. So we have done. Hold on. This is not correct here.
That should be 4.
No, that will be how many? 8. So it has to be 4. So what I will do, yeah, what I will do here, how about with this one 2? Oh, sorry. 2 here and 2 here. So 4 and 4, 2 multiplied to 4 plus 4 makes 8. Atomic mass. And then 4 and 0, 4. 2 and 1, 2. Yeah, 2. This is not a decay here. The decay is alpha decay because we don't have hydrogen. That's an isotope, deuterium. If we have a proton deuterium, it has to be 1/1. This is 2 here.
Yes.
So that's not a decay of deuterium. That's a decay of helium. Okay, that's correct. And the whole reaction is fission because you are bombarding this element, creating a new element, which is in this case out of it. So see that? Number 7, this is 7. That's the answer here. This is 7 here. When you bombard uranium with neutrons, you are producing 2 elements or 3 elements, 1 element. That's called what?
Vision.
And all those decays. Can you see those? Beta plus or positron. We call it positron here. Positron. Or sometimes some textbook will say it's beta plus. Okay, so I think this is good for this chapter. Let's go for covalent now. Okay, naming. Covalent compound. Tab of with yours. Same thing, so you can then. There are too many of them here. Like the really here. Like you are like Pili for some reason. I don't. But yeah, whatever you like, you tell me. It's open. See and select one.
Let's do
One.
homework 7. Homework 7.
Homework 7. Homework.
Okay.
It's here, yeah?
Yes.
Okay. That's the answer. It's given to us. It's not good. We don't need the answer. Yeah. We need something is without the answer. Let's go back. Yeah, we need one without the answer so we can try them ourselves.
Practice work.
Which one?
Naming compounds. Practice worksheet.
Here?
It's done.
My chemistry naming. Which one? Here it is. practice
Yes.
worksheet? Yes, that's at least if their answer, the answer will be at the bottom. And those ionic versus, those are ionic, but we can start with ionic. That's ionic.
Oh, that's ionic.
Yeah, I mean, it does not matter. With single charge and multiple charges. It looks to me those are different, multiple and single. So let's do single one. Single one, you have to have the sheet near you. So this is the single one. Aluminum has 3 plus. So you wanna do this one here? So do 10, the following compound, 10 and 7, 2 and 1. Write it down. 1, 2, 7, and 10. And take snapshot of them and then answer them. See, this is a whiteboard here. There is a whiteboard. There should be a whiteboard somewhere. Not sure.
7 is PPSO LCM.
Okay, so number one, what is the name of it? Number one,
And if no, this
what we call number one? Top, yeah.
yeah. That is ammonium chloride.
Ammonium chloride, correct. How about the second one? Second one. Look at it carefully.
That will be, let me see, iron 3 nitrate.
What's that? Iron what?
Iron 3 nitrate.
Yes, the Roman number 3, correct. That's perfect. So you get that correct. How about number 7? You don't Google the answer, correct?
No, sir.
Okay, good, good. How about number 7?
That's 7. This is lead. Lead. Nitrate. Will this be SO4? What is SO4? Lead 2, lead 2 sulfate.
Sulfate, lead what?
Is it lead 2 sulfate?
Now, look at it again. Sulfate is -2. The sulfate is -2. And yeah, the sulfate is -2, correct?
Yes.
So the lead will be what charge on it? +2?
+2.
No. Before plus, because you have to have the positive charges has to equal the negative charges. So the lead here, look, you just write it here. It's 2 plus, correct?
Yes.
But the sulfate is 2 minus. So the lead sulfate, as you said, lead 2 sulfate will be this one here.
SO4.
The lead is 2. But since you have 2 sulfate of those, so one lead here, and you have 2 of the sulfate, SO4, SO4, and both of them 2 minus, 2 minus. So total of those here is 4 minus. So the lead has to be what? 4
Lead.
positive, correct? To compensate for this. So it will be lead 4 sulfate, lead 4 sulfate, because lead has 2 predominant charges, multiple charges is 2 and +2 and +4. So that will be lead,
Lead 4 sulfate.
lead. Okay, last one. Last one. Can I take this? It will be, I mean, in the recording, so you can go back and take a snapshot of it later on. But let's do the other one.
Okay. Number 10.
10? Yeah, let's do number 10. Yeah.
Trying to see what CN is called.
What's that?
I said CN. I don't know what CN is called.
You want to look it up?
Yeah, I want
Or want me to give it to you now? I'll give it to you now so you can look it up. That's cyanide. Cyanide. Cn minus.
Okay.
So this is
Yeah,
if one charge. And the name of
nice.
cyanide.
Yeah, nice. Okay. That's one. That would be aluminum cyanide.
Aluminum cyanide. Do we have 1 or 2 or 3 aluminum 3 cyanide? No, because aluminum has only one single charge. 3 plus. So no Roman number. The aluminum cyanide. Okay. Now we did that for the ionic let's make it for the all those are, unfortunately, all those are ionic. I need to do some covalent. Yeah, they charge money. We don't need money. Okay, yes. There is a key, but we are not looking at the key. So choose any of those you like. I like 24. 24. 28 maybe. And 26. So I'll give you here. I'll circle those. 24. 24. 5. 26. And 30 here. 29. So put the name of them, and then we'll turn to note that the what they call it, if I give you the name, you write me the charge.
Covalent is EH3.
Yes.
EHs. Okay.
Number one, what you say?
Phosphorus.
What we call it? Forgot.
EH3. I know three.
Yes. What you say?
Would that be uh, phosphorus, hydrogen nitrate, phosphorus, hydrogen
No. Forget about the monohydride.
nitrate,
Hydride.
hydride.
Hydride. Okay. So number 25.
Hydride. E2BR4. Will that be dibromide?
What's that?
Will that be
Uh-huh.
dibromide?
No. You start with the first element. The first element is bromide. No. Diphosphorus.
Phosphorus bromide.
Tetra.
Bromide.
Tetra for bromide. Yes. Diphosphorus. Yeah. How about 25?
NH3.
You need some work with this. You
Yes.
need some work. So
Nitrogen.
you have to do. You have to write yourself a note that you need to try those.
Water. Is it that?
The metal, the ionic. That's the most difficult one. You know it, but the most easy one, you have difficulties in that. So I don't understand.
Nitrogen trihydride.
Which one?
NH3.
And actually, nitrogen trihydride, or we
Hydride.
call it ammonia. That's correct. Nitrogen trihydride. That's correct. How about number 25? Don't skip 26. Don't skip it. I want to hear it. See,
Okay.
what we call this?
Mhm. Mhm. Nitro- Is that cobalt?
What's that? That's not cobalt. The elements are always the first alphabet is capital, the second alphabet is small letter. That's not.
Oh, is this? This is capital C and O, right?
Capital C and capital O. Carbon C, oxygen is O.
Yes.
What we call it?
The carbon right? One has no number. Is that carbon? No, there's no two there.
We need to do a lot of work here. We need to do a lot of work. Yeah, you need really to, because
Need to go.
the very difficult one you get it very quickly. So this is carbon, one oxygen. First, always the first element. First element is
Carbon.
carbon, so that's carbon. One oxygen, understood, not written. That's monoxide. When not say mono, then pause and oxide, monoxide. Just one of the vowels O will be deleted. Monoxide.
So it says
Okay.
carbon monoxide.
This is carbon monoxide. Yes. And we have CO2. That will be carbon dioxide.
Right. That is
How about number 30?
NO2. Okay. Nitrogen dioxide.
Nitrogen dioxide. Now, you will get something looking the opposite. Let me take this one out. Here I give you the structure and you get the name. That's easy. But how you pick up two of those or three, I will give you numbers now to see how you write me in the chat. I'm going out. Write me those here. This one here.
Okay.
And
Nitrogen.
three ones. Write me the structure of the formula, the structure. Take snapshot of them. I'm taking snapshot of them so I know what I asked. And then write me in the chat the answer.
Okay.
Or you can write me the answer. So tell me what the type, what the alphabet I can type. I write not type but write. So here it is. You have, so 31. What is the formula, the structure of it will be looking like?
31.
Always you have the elements. You have chlorine and you have nitrogen. So just like nitrogen and chlorine, that's the two elements there.
Yes.
And then you have nitrogen, then you have tri. So
3.
yeah, so that's easy. So here we have nitrogen and oxygen. So we have nitrogen, oxygen.
2.
However, I have dinitrogen, so I have two nitrogens.
2 and 3.
I have 3.
Yes.
So boron, I have boron here, 2 elements. I have to start with the elements. And then hydride, I have hydrogen. So diboron means 2 boron. And tetrahydride is
4.
Tetrahydride is 4.
Yeah.
How about carbon disulfide? Carbon S sulfide is from sulfur.
So
Then the di is 2. How about nitrogen monoxide? Nitrogen, and then oxide is nitrogen. So it's here. Monoxide, not mono-oxide. So means 1 oxygen. Understood, not written. 1 is NO.
Yeah, this is easier than.
Yeah, but you are struggling. I think you need some help with this. So do a lot of worksheets too, because there's a few questions about this. So you have to be ready when it comes to the test and the quiz. So let's look at this. And then the next topic is the whisper. We'll go now for whisper. Shape of molecule. Okay, so we'll go to the shape of the molecule and the polarity and type of the bonding. Okay, so let's look here. Whisper worksheet. Have the same thing I did. Whisper shapes of molecules worksheet. Okay.
Yes.
And hit enter. Then select any of those. You have plenty of those. So look at one of them. One is enough here. And then you can do your so few of those. Polarity will determine the polarity.
Yes. We will do the worksheet.
Yes.
The worksheet.
Whisper shapes of molecules worksheet. Whisper shapes of molecules worksheet. Look at one of those. Tell me which one you like.
We will do the Vespa worksheet.
Yes. Which one? You get the same thing I got?
Vespa worksheet. Yes. This.
Whisper shape of molecules worksheet. Shapes of molecules. Whisper shapes of molecules worksheet. Okay.
Yes. You want me to choose out of the 3?
Choose one of them.
Okay.
I will do polarity and then bonding types. That's it. And then that's all the study guide. Quiz and exam.
Okay,
So
can
this
we
one.
do this Lewis structure, Vesper theory, and
This one here.
yes, sir.
That's just more explanation. It's not
Mm-mm.
see that's explanation, but we can do those if you want to.
Yes.
Okay, so that's we did those. So yeah, that's we did those. So let's see. So H2O, what's H2O? What's the shape of H2O?
Bent.
Bent, just memorizing from the whatever the whole thing there. Okay. How about this one here? How we draw CH2Cl2? CH2Cl2. How we draw it? What's the shape of this?
Let's see. CH2, Cl2.
So what's the shape? What's the angle? How many regions? What's the total bar?
One,
What's
two,
the
three,
total? What's that?
1, 2, 3, 4. We have
Four,
four.
four regions. We have four regions, four single bonds, four regions. Okay.
Yes.
And the question is, what's the shape of this? What's the shape of this?
CH2.
A, central atom. This is B. This is B. This is B. So this is A. Four. What's AB4 according to the table you have? That's what name of it. Tetrahedral, correct? You have to have this handy for you so you can. This is AB4 tetrahedral.
Tetrahedron.
Is it polar?
Form.
Yes or no? Yes, polar, because you have not identical atoms over there. There are two different atoms there, so it has to be polarity still there. Polar. What's the angle of it? Since it's tetrahedral, lone pair, it will be 09, 5.
1.5.
What else we have to know about this? Well, we have to know about this regions. How many regions we have? 4. Just look at this number here.
Yeah.
4 regions. 4 regions means what? 4 single bonds. Yeah. I can't write on this. I mean, it's just very awkward. This laptop of the university is not touch screen single. I'm just writing it with the mouse.
Good one.
Okay, 4 regions. What more? What is the number of the total VEs? What is the total of the VEs? Can you calculate?
V is
Valence electrons, how many for the whole molecule? Or not the VEs, total of all the, yeah, I need the VEs. I need the VEs. That's what we really, they are really participating in the whole bonding, the VEs, not the other ones. So
H2. Okay, let's see.
Chlorine is 7. The other chlorine is 7.
Yes.
Hydrogen is 1. Hydrogen is 1. Carbon is 4. So 7, 7, 14. 14 and 4 is 18. 1 and 2, that's 20. Okay? Now do for me this.
Z is 12,
No, not 12.
not 12.
That's
Oh,
20.
10,
That's 20. 20.
it's 20, yes, it's 20.
Okay, so polar 4 regions, total of the valence electron angle. Yeah, we no lone pair. Lone pair is 0. There is no lone pair on the central atom. The code is AB4. That's the code. That's it. So now let's do for me this. Molecular form.
BCM.
Phosphorus is being what? Central atom. Here's oxygen. Here's chlorine. I give you even hint.
3 chlorine.
I'm just interested in oxygen to obey octet, but the other ones are not. The other ones are not. Oh, sorry. So we have almost how many? Almost 8, 2.5 hours. Students, when they look at the whole thing, they might fall asleep, I think, after 2 hours of reviewing. But anyway, so everything is recorded. So what's the bonding here? You tell me. Phosphorus has 5, so 1, 3, 4, and 5. Oxygen has 6, 2, 6. This is chlorine has 7. So that's we did not take it, but at least you would know that A, we did not cover this one here, but at least A or B, A, terminal is one B, 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 A, 1, 2, 3, 4. A, correct? How many we have? 3 and B, 4. No lone pair. No lone pair. Correct?
Yes.
So how many? 3 carbons, 3 chlorine, and one oxygen. That's 4. So what will be then the whole structure? I mean the whole shape. AB4. What's it stand for? Tetrahedral. Correct. That's the code here. This is it's the same. This is tetrahedral. Correct. Tetra. And the angle is
109.5.
5 degrees. Then how many we have? We treat them the same thing. How many zones or units or regions? Zones or regions or units?
Oh.
Or regions, 4, correct. This is AB4, correct. So it will be 4 here. So it is polar, non-polar. It is polar because we have one atom is different from the rest of the atoms here. One is different. So oxygen is different from the 3 chlorine, yet it is polar. Correct. Now, what is the total VE value? What is the total of VE value? Can you tell me? Well,
let me calculate it.
Okay. You tell me. Chlorine 7, oxygen 6, 7, 7, and phosphorus is 5.
5.
Yes.
7 times 3. 11. That's 32, 34. Oh, no, 32.
Which one?
32.
Yeah, 7 multiplied by, you have 3. 7 multiplied by 3, 21. 21 is 5. That's 26. 26, 6, 32, correct. So I think that would cover, so you can still, you're good in that. So I don't have any problem. This, we did not do any chart, but you can do the CO2. Okay. That this, you can do this. Some of them we did not do the SE. SE4 we did. PR5 we 1, 2, 3, 4, 5. We did not do for the 5. We up to the 4. So don't worry about the 5 here. So, but anyway, you can do the rest of those here. So you might try the B5. You can't try the other one. So, but there are plenty of examples to the whole thing. Now, we talked about the polarity, correct? It's clear with you the polarity. If the atoms are identical around the central atom, this molecule is not polar. If you have a lone pair on the central atom, blindly you can say this molecule is polar, correct? Makes sense? Okay.
Yes.
Now we need the last topic here is the types of bonding. Types intermolecular bonds. Worksheet. Types of intermolecular bond worksheets. We have 4 types. I mean, there are many other types, but the main thing is start with dispersion. The weakest one, just dispersion is just delocalization of the valence electron from one side of the for a few seconds. I mean, it's not taking that time. It's not a big, strong forces. Then we have dipole. We have hydrogen bond, and then we have ionic bond. So we have dispersion bond or intermolecular forces interaction. we have dipole-dipole molecular interaction, we have hydrogen bond interaction, and we have ionic bond interaction. So choose one of those and tell me which one you like. IMF, intermolecular force. Let's see if this is a good one. I don't know. Yeah, that's a good one. That's a good one. So they gave you all the ones you like. Hydrogen bond, dipole-dipole. London means dispersion. Dispersion. And you can say if this is polar covalent, you have to have the table ready. You remember the table still?
Yeah.
From 0 to electronegativity different. Correct. The difference between that is non-polar covalent. Non-polar covalent. Okay. So then greater than 0.4 to 1.8,
Covalent.
1.9. This is
Covalent.
covalent polar. That's electronegativity difference, correct? We are
Yes.
looking at the delta electronegativity and En, and greater than 108 or 109, that's ionic. Okay, so that table you have to recall it and you have to have it handy and ready. So let's pick up two or three. Let's pick up three and tell me what interaction in this intermolecular forces interaction in this molecule and whether it's polar or non-polar. Which one? Yeah, those are the types here. This dispersion here, called dispersion here. This is 1, 2, 3, 4. And here the polarity. Okay?
Yes.
So which one you like? I want to see this. I'll give you some, then you can tell me. And then you can pick up your own. 16, I like to see, and 17, and 9, and maybe 5. So choose 5. Iodine. 16. Then you can choose 2 of yours. So tell me what's interaction of this. The only thing I can know what's the interaction, I have to draw the Lewis structure. I have to know the Lewis structure. So the first one, the Lewis structure of the first one here.
No.
Hold on, BCl3. Enter the Lewis structure of phosphorus. So that's the Lewis structure, correct?
Yes, sir.
So you can see that has to be polar because it has what? Central atoms have what? Lone pair. So this
Okay.
is polar covalent. So that answers this question here. But what type of the whole thing is? Well, it turns out to be that's not a hydrogen bond. The hydrogen bond will tell you the presence of hydrogen combined with nitrogen, or hydrogen combined with oxygen, or hydrogen combined with fluorine. So, and this is not ionic, there is no metal, correct? The only thing you're left with is dipole. So you have a dipole here, pulling these valence electrons of phosphorus. And then you have another molecule of this, correct? So another molecule of this, like this one here, whatever. So the phosphorus is pulled out something like this. The one here. What I mean, this one here. So this is dipole. So this one here is dipole. So the first one here, this one is dipole. It's here, correct? And it's covalent, correct? Now, okay, so we don't need to do electronegativity difference, but we can do electronegativity difference between chlorine and phosphorus. The electronegativity, I think, is 3.0, and this is 2 point something, 2.5. I'm not sure, but it will come polar, but polar greater than 0.4, greater than 0.4, or 2.0, I think. So you can see how much is the difference between phosphorus and chlorine. 3.0 minus 2.5, 2.0, and I think it's 1.0. So that's covalent, covalent polar. So, and the iodine, do you have this? You have this already? I'll take the iodine now. You ready? Can I take it out?
Yeah. Yes, sir.
Okay, now let's look at the iodine. Iodine is, you have to, in order to know, iodines look like this, correct? Meaning if I want to draw the Lewis structure of it, iodine is group 7A, it has 7 electrons, so it is.
There you go.
2, 2, 2. So this is linear, correct? The shape
Yes,
of it is linear, but the problem is that the delta En, what will be? The same element, correct? Zero.
Yes.
Zero. They would cancel themselves out. It's not the dipole. This will be pulling this. The same still in the opposite direction will pull the other one. So the net zero, the difference between electronegativity will be zero. Whatever the iodine electronegativity minus both, they're canceled. So this is non-polar. So this is non-polar covalent. Covalent means there is no metal. So what type of the whole thing is ionic? It's not ionic. It's hydrogen bond. There is no hydrogen bond between, you say this one hydrogen bond is hydrogen and nitrogen, between hydrogen and oxygen, between hydrogen and fluorine. So it's not hydrogen bond, it's not ionic bond. It can be one of those here. Dipole, there is no dipole, they cancel themselves out. So the only left on it is nonpolar because delta E, the electronegativity difference, is 0. So it will be
Zero.
abundant forces or dispersion forces. Okay. Then what I told you about what the next one? What the next one I gave you? 16, correct? 16 and 17. 16 is the same thing, but 16 is CaO. It's calcium oxide. Calcium has 2 valence electrons. Oxygen has 6. Now the 2 electrons will be transferred here. So it loses to oxygen. So therefore, the Lewis dot structure will be looking it's calcium 2 plus, losing 2 electrons, and oxygen will be 2, 2, 2, 2, and those 2 is coming from calcium. Therefore, oxygen will come appears minus. Of course, if you make a difference between oxygen and calcium, oxygen is 3.5. Calcium, I don't know, look it up, but I don't know what calcium is, but it has to be, this is ionic.
1.0.
1.0. 1.0, so it is 1 point. So the difference is 2.5, correct? That's greater than 1.5. So this has to be what? Ionic. And it has a metal though. So that is, this one will be ionic. Yeah, okay. So you pick up now one of your choice, and then you have to do the Lewis dot structure to know what type of metal, and then you do the difference electronegativity. And then you can determine whether it's dipole, or ionic, or hydrogen bond. Hydrogen bond is easy to recognize, and ionic is very easy to recognize. Ionic, if you have a metal, that's ionic. The hydrogen bond, you have to have hydrogen connected to nitrogen, or hydrogen connected to fluorine, or hydrogen connected to oxygen. And the dipole is just remaining between dispersion and dipole. Look at the electronegativity difference. If it's from 0 to 0.4, that will be dispersion. If it's greater than 0.4, that will be dipole. If there is no metal and there is no hydrogen bond. Make sense?
Yes.
So you want to pick up one, and then we'll call it off for today. So now pick up one and see if it's polar, non-polar, or it is hydrogen bond or ionic bond.
See, 11.
Which one?
Number 11. Yeah.
What number?
11.
11. Okay. What you have to do first, we said you have to put
CL. CL in the middle. Okay. CL.
4, 5, it's 5, 7, and then you have hydrogen has only 1. Hydrogen is 1. What's the shape of this? What's the shape of this? It's
Okay.
A, B, B. This is AB4. That will be what?
Tetrahedral.
Tetrahedral. Okay, so what do you think it is? It's polar or non-polar? Because we are answering one of those, polar or non-polar.
Okay, let me calculate this.
Remember, you have 3 hydrogens identical, but one is different.
Yes, that's polar.
One is different, so
Polar.
this is polar, correct. So we answered this. The question is, it is hydrogen bond or ionic or dispersion or dipole. So dispersion means always this is non-polar, so you can exclude this. When we said polar, correct? So this,
Yes.
you have to exclude this. So this one here can't be, it's out. And ionic, there's no metal. Hydrogen bonding, there's no hydrogen with nitrogen, hydrogen with oxygen, so out. The only left is dipole. Here is, one is here from carbon, valence electron, is chlorine. Chlorine is more electron, so it will take this one here. That's a dipole here, beginning of it is. That's the dipole. Then you have another molecule near it, will be then pulling the other carbon as well. So you have this dipole. If you put another one like chlorine here, I mean, and here's hydrogen, here's chlorine, correct? So this one will be pushing this way here, beginning of the dipole is here. And now you have this hydrogen here, correct? So hydrogen will be pulled out. So you have still relationship dipole. This has a dipole, this one has dipole. Well, the interaction will be dipole. Okay? Make sense?
Yes, sir.
Okay, good. So I think almost 2 hours. I think that's it. That's all the study guide. Do you have any other questions you have? Done already, correct? So I'll stop sharing. So you have any other question? I'll stop recording in a minute. So any question you have or stop recording? Any question?
Yeah, that I want to get how the A and B thing on the bond.
A and what? Type this one here. What do you mean? A and
Yeah, how you get that
type
code?
in the chat. Type in the chat. What's your
How
question?
get
Type it in the
how to determine the code in the bond?
well, determine the code. That's I told you. You have to have lose that structure ready and correct. And then the central atom is the least electronegative atom will be in the central atom. There's some exception for the rules, but most of the time, over 99%, the least electronegative will be put in the heart and the core in the middle of the molecule. That will be your A. The terminals regarding whether equivalent, whether there's different, whether they're the same, you give them D. You give them D.
Okay.
They calculate number of the terminals. If there are 2, that's B2. If there are 3, B3. If there are 4, B4. If there are 5, B5.
So,
With the central atom is A. Yeah, the central atom is always 1. It's A.
A. Okay.
Okay.
Yes, sir.
Okay. So I'm stopping the recording and.